Hey guys, today we will be doing a Vpython simulation of the Earth-Moon-Sun system, and it will look like this. There's the Sun, and if we zoom in we can see the Earth and the Moon orbiting around the Earth. For this simulation we will break it into two parts, the first part being the Earth and Moon system, and the second part adding the Sun into the system. So for this simulation there are two key points. The first one is that instead of one object revolving around the other object, the Earth-Moon system is actually two objects revolving around the common axis, and the common axis is their center of mass. So we have to take into consideration both the force acted on the Moon by the Earth as well as the force acted on the Earth by the Moon. Yes. To start off, we can define a few functions first. Right here, the g-Earth means the acceleration caused by the Earth. And when we define a function, we need to give it a name, and we need to give it the values input into the function. So for example, right here, when I want to calculate the gravitational acceleration on the Moon caused by the Earth, I have to feed the function two values, which are the Moon's position and the Earth's position. So when a g-Earth function reads these two values, it will calculate the vector EM, which is the Moon's position minus the Earth's position. And the value it will return, which should be the acceleration, will be negative g times mass of Earth. Here I create the mass using a list. Okay, so negative g times mass of Earth over the square of the magnitude of this vector, and the magnitude of this vector is actually the distance between the Earth and the Moon. So it's just over the square distance times the unit vector. And we can do the same thing for the gravitational acceleration caused by the Moon. So we define another function right here, and we'll use it right here. Okay, so now we're done with defining functions. Oh, and you can also put this formula in your while loop, but defining as a function will make your code clearer and more readable. Okay, and now we want to set the Earth and the Moon's original position. So instead of setting the Earth at the origin, I want to do this because, like I said, the two objects will be revolving around their center of mass. So my ideal situation will be that my center of mass is right at the origin. So to do so, the Moon's orbit r means the distance between the Earth and the Moon. So if I want my center of mass to be at the origin, my Earth should be this distance away from the center of mass, this distance away from the origin. So negative Moon orbit r times ratio, and ratio is right here. Okay, and the Moon will be on the positive x direction from the origin, and distance from the origin will be this one. So this is the first thing, and the second thing is because when the Moon revolves around the Earth, they don't do it in a 2D dimension. It's not flat. Like it actually revolves with an angle theta. So theta is right here. So in order to make the revolving the orbital plane tilted toward the positive x direction with the angle of theta, I will set the initial position of the Earth and the Moon at negative cosine theta times its distance away from the origin, and the y will be sine theta times this one. This is for the Earth. As for the Moon, it will be cosine theta times the distance away from the origin, negative sine theta times the distance away from the origin. Right. And right here, you can see this one. Texture, file textures, Earth. I think this is pretty cool. Just like you saw in the simulation, the Earth will actually looks like Earth, if that makes sense. Yeah, this is cool. Okay, and now as for their initial velocity, the Moon's orbit v is just literally the velocity that the Moon orbits around the Earth. And the reason why I don't set the Earth be at 0 is actually very similar to why I set the position at this one. Because if I set the Earth velocity at 0 and the moon's velocity at this one, this only, then you will notice the two objects moving in a negative z direction because their linear momentum is not 0. So in order to make the linear momentum 0, this is what I do. I times the moon's orbit velocity at a ratio or 1 minus ratio. This will allow the moon's and the Earth's relative velocity still be the moon's orbital velocity, and their momentum will be 0, so they won't be moving toward the negative z direction. Okay, and this one right here, scene center Earth position, it will set the scene center at the Earth position, literally. So now we are going to move on to the while loop. One thing to notice right here is that for this part, you want to first calculate the moon's acceleration and the Earth acceleration. You want to calculate these two before you proceed into calculating their position. This is because we will feed the functions the position of these two objects. And if you calculate this one, the moon's acceleration, and then you do this, and then you do this, and then you go back to this one. When you go back to this one, the Earth position and the moon's position, especially the moon's position, is already not the position you want. And that would yield some terrible consequences. So you do not want that. So make sure you calculate both accelerations first. Okay, so this is the part for the Earth-Moon system. Now we will add the Sun. So same thing, we define a function g sun to be the gravitational acceleration caused by the Sun. And the Sun is right here. So we want to set the Sun at the origin. And here you can notice this one. Seeing lights blink, this turns off the light in the simulation world. In emissive true, this means the Sun will emit light. In local light, position vector 0, 0, 0. This is the position of the Sun, so it means light will be emitted from this point. Okay, so right here, one thing we have to notice is that now both the moon and the Earth is also affected by the Sun instead of only affected by each other. So you have to make sure that you add the gravitational acceleration caused by the Sun to those two. And I think that's about it. So let's take a look at the simulation again. Sun's right there. And actually the Sun is at the origin, but because we set the scene center to be the Earth position, so it will seem like the Sun is revolving around the Earth, which is not exactly the truth. And right here. And you can see the light side and the dark side. That's because we turn off the light in the simulation world, and then we give the Sun the emissive ability. That's why. And you can see the moon revolving around. And if you look at the simulation for a longer time, you will see that in the beginning, the orbital plane of the moon is tilted like this toward the positive x direction, and over time it will tilt toward the negative x direction. And then if you wait a little bit longer, you will see it return to this position. That's called the precession of moon. And that's all for today.